Hi everyone, I'm going to be going over question number 56 from the Chapter 8 Bingo Problems. Now this problem is kind of interesting. I'll read it. It says, at one instant, the center of mass of a system of two particles is located on the x-axis at x equals 2 meters and has a velocity of 5 meters per second, I. One of the particles is at the origin. The other particle has a mass of 0.1 kilograms and is at rest on the x-axis at x equals 8 meters. So part A wants to know, what is the mass of the particle at the origin? Part B wants to know, calculate the total momentum of the system. And then C wants to know, what is the velocity of the particle at the origin? So we'll start with part A. And like I said, it wants to know the mass of the particle at the origin. So I split up the information we're given. So here's, at this instant we're talking about. So the position of the center mass is at x equals 2. The velocity of the center mass is 5 meters per second in the I direction. And then particle 1, it's at the origin, but we don't know anything else. Particle 2, 0.1 kilograms is a mass. Its velocity is nothing, and its position is at, I'll just leave it at x, is equal to 8 meters. So for part A, finding the mass of the particle at the origin, so that's going to be particle 1. We're going to use our center of mass equation, which is going to be, so our center of mass is going to equal m1x1 plus m2x2 over m1 plus m2. So, our typical center of mass equation. But we know that this is 2, so we can, we'll leave that, we'll rewrite it. So 2 equals this. And so all we need to do is kind of figure out what we've got going on. First of all, the position, which we have as x here, of particle 1 is at the origin. So this is going to be 0, which will cancel that. That's just going to be 0. And the rest we can just solve to find m1, because that's going to be the mass of the particle at the origin, particle 1. So to do that, we end up getting that, so I'll erase this part that cancels out just to make it a little nicer to look at. So what we end up with is it's going to be, and let's just throw in some values. So 2 equals m2, which is 0.1 times x2, which is 8 over m1 plus m2, which is 0.1. So when we multiply this out, we end up with m1 equaling 0.3 kilograms. So now we know the mass of particle 1. So now for part B, what it wants to know is it wants to know the total momentum of the system. So we know the momentum is, P equals mv. That's momentum. But for us, we're going to be dealing with the center of mass. And so it's going to clean up pretty nice. So we're going to have P is going to be equal to M1 plus M2 times VCM, which is the velocity at the center of mass. And so when we plug everything in that we know, we'll end up getting, since we already know the velocity at the center of mass, we get the P, or the momentum, is going to be, we know it's 0.3, and then plus 0.1, so we'll just add it right here. We'll say 0.4 times this, which is 5, I, and we're going to end up with 2.0, so the momentum is 2.0 kilograms times meters per second in the I direction. So that's it for part B. We found the momentum of the system, and we did that using the velocity of the center of mass. Now what it wants us to find the velocity of the particle at the origin, so this right here. And we can do that through the velocity of the center of mass using the center of mass equation, but instead of position, we'll use velocity. So we'll end up with VCM equals M1 V1 plus M2 V2 over M1 plus M2. Now we know everything here except the V1. So when we solve for that, we'll end up getting, we'll end up with V1 is equal to 6.67 meters per second, and that's in the I direction. So our velocity of that particle, like I said, is 6.67 meters per second in the I direction. And we do that just, by plugging in the values we have here. So if I want to do that real quick, M1, 0.3, V1, that's what we're looking for. This is 5, I, mass 2, 0.1, times the velocity, which is 0. So that all cancels out. Mass 1 plus mass 2 is going to be 0.4. So what we end up with is 5 equals 0.3, 0.4 times that by 4, we get 2, we just do the math from there. So anyway, we end up with 6.67 meters per second in the I. So anyway, that's about it. So hope you learned something, and I'll see you in the next video. Thanks for watching.